So we will be gonna talk about SSL profile as well. Okay. And somebody wanted to have some questions, right? Probably all of the questions you can ask today. Okay. That today is the good day to talk about any of the SSL related questions, what you had in your mind earlier. Okay. So let me start first. If we will talk about the profiles, what is profile? Maybe in the theoretical term, if I will talk about, profile is nothing, but you can say it is a configuration objects. Okay, we can say configuration objects or maybe configuration tool, whatever you say. So it is nothing but the configuration tools or objects which provide a way to define the traffic. Okay. Now, why you wanted to define the traffic? Because as per the traffic, I will say traffic behavior, we can use the traffic setting which can be more efficient for the application perspective. So profile is the configuration tool, I will say, that we can use to affect our behavior of certain type of network to increase the performance. And throughput, whatever you can say, on the network. So that is how like profile is working. Okay. So I hope we already gone through it. We discuss about the same. Let us now maybe talk about some of the profiles. So if you see this particular slide, here we are talking about some of the profiles. One out of that we have already discussed, and that is persistence profile. Similarly, there can be TCP profile, there can be FTP profile, there can be compression profile, not used nowadays, cache profile, one connect profile, and lot of other, including the SSL profile. So lot of profile exists. Okay, one by one, I will try to give you the overview about those which are maximum used in the environment. Okay, so by applying these profiles, you can change the application behavior. Okay, so these can be applied directly onto your virtual server. So within virtual server, if you see, there are a lot of profiles available. You need to apply a couple of the profiles over. Okay, so it would be get applied where? On the virtual server. Now let's start with the first thing, that is SSL encryption. So what is SSL encryption, if I will ask anybody? Am I audible?
Yeah, you are audible.
Okay. So anything what you wanted to share about the SSL encryption?
Encryption it uses some keys to encrypt the data.
Right. Perfectly fine. So as Ambrish is mentioning, encryption is what? Like we have a data, hello. Maybe the popular two words when we learn any of the language, hello world. If I need to share this data over some of the transport like internet, anybody can watch out this and can use this data. But this data is not important. What about if we are having the credit card information, if we having the username, password, and maybe I will say the critical information is there. We cannot send it on the wire in the clear text form. And for the same, we need to encrypt it. Again, encryption is not the new technology. which we are using on the F5 only. If you talk about GRE tunnels, IPsec tunnels, DMVPN, maybe SD-WAN, and any SDA, or maybe the ACI, all over. It is talking about the Cisco probably, but if you talk about Polo, if you talk about any other vendor, encryption exists every, right? Here also encryption occurs. I will be going to talk about encryption in some more details. First, let me go through these slides, okay, or maybe through this I will say PPT, and post that I would be going to show you some more details about the encryptions. Now, here we will be going to do the encryption through the SSL profile. Okay, and so through the SSL. Now, what is SSL? Probably I will be going to come to the SSL and TLS, these kind of things again. Okay, but currently, if you see this slide here, what we are saying that there is two terms, certificate and keys. On the basis of this, your SSL protocol works. SSL for now is then obsolete. The new version is TLS. Even TLS earlier was 1.1, then 1.2. Currently, even we don't prefer these as well. We prefer 1.3. Okay, so this can be an interview question as well. So please mindful or put your focus over here. Okay, be attentive with these kind of things. Now, these things will do the encryption end-to-end. How end-to-end? Like from the client, if some of the request is coming, it is going even through the internet, reaching to the F5. From here to here, the things will be in the encryption way. And that is why we will say HTTP S stands for secure. Got this point? How all of these maybe handshake happen? Probably I will be gonna touch that part also. I will be gonna talk about that part. But first, let us go through this generic thing. Then I will be going the deep dive, and probably I would be giving you 5-7 points like how the things happen. And if you are aware about VPNs, okay, you have gone through the VPNs. Probably same thing, the Diffie-Hellman key and all of those stuff. Probably you can relate the same thing over here. Okay. So this encryption now on F5, when traffic is coming, it is encrypted. F5 will do it the decryption. Why decryption is required on the F5 end? Because if there need to be modified any kind of traffic behavior, then how F5 will be able to see it? It requires the decryption on the F5. Once the decryption part is done on the F5, F5 will be do some modification or maybe anything what it need to be done, and can encrypt again to the server. Okay, when it is sending to the server. Or it can be a plain traffic, because your server and F5 are residing to the same data center. Is this part clear? Now, when would be the what would be the scenario? How it can be happen? Again, I will be going to touch that part. Please have patience. But these kind of scenarios can happen. Okay. Now, the encryption and decryption. Probably I will say about the encryption and decryption what you are doing on the F5. It required some kind of SSL acceleration cards. Okay, these can be hardware which is residing into your chipset, okay, into your F5 box itself, and this takes that load from the server, and F5 will do that kind of thing on behalf of server. So that is something known as server offloading. Hello, am I audible, guys?
Yep.
Yes, yes.
Okay. Let me show you through this slide. Probably you will be able to understand more. Here in this slide, you can easily able to find out using the profiles. We are using here the SSL profile. Using the profiles, what is happening from client to the F5 over the internet, traffic is encrypted. Whereas, since these two components are residing into the same data center, we are saying that, okay, it can be unencrypted. Why to put unnecessary burden on the servers? Okay, so it is the plain traffic, unencrypted traffic. And this possibility is very much happens in the environment.
And that is SSL offloading.
I will be going to talk about it. Yes, but you are right. That is SSL offloading. Now let's talk about the traffic flow. What would be the traffic flow? Client is sending the packet over the internet to the F5. F5 BigIP will receive that encrypt traffic and decrypt it, do the all kind of load balancing and whatever it needs to done, and send it to the pool member. Pool member has the unencrypted traffic, so it will be sending the unencrypted response, and it is gonna send, when it is gonna send on the client over such a medium which is not secure like internet, it will be get encrypted again. Okay, now let's see what happened, how F5 will able to do it. Okay. Currently I am just giving you the overview, then we will be gonna talk about more about it. So how the thing happens when there is some kind of key exchange, okay, whatever the key exchange, just don't focus on how that key exchange happens, because that is the curriculum, and today I would be going to explain about that as well. But just think about that there is some kind of key exchange, okay, that it is sending a key and one key should be on the BigIP. Now all of the keys from the server, where it is now we are putting on the BigIP. Okay, how to put, again we will be going to talk about that in practical manner. But yes, your BigIP should have all of the keys available. Okay, so this key is the private key, just FYI, but we will be going to talk about things, how the public key happens, what all of those things we will be going to talk about. But all of these certificate management centralized point is what? Centralized point is BigIP. Okay, and on the BigIP, all the keys will be there. Now, it offload the SSL traffic work from the back application on the BigIP, and that is the reason it is known as SSL offloading. Okay, now what is SSL offloading? SSL offloading is when client is sending a request on the F5, and from F5 it is going to the server. Maybe let me make this diagram generic and write down over here SSL offloading. So in SSL offloading, this packet will be encrypted, and this packet will be plain text or maybe unencrypted. Second is something SSL pass through. In this case, this is encrypted. And when Fi will generate the traffic, it will be also encrypted. And the third case is SSL. I'm sorry.
In SSL pass through, it will
No,
not.
wait. I just explained you about SSL bridging. And the last is SSL pass through. Pass through means we are just passing the traffic, means Fi will not intervene. And this is encrypted end to end. Remember I talked about the full proxy and all of the stuff that Fi always is not full proxy. So that is SSL pass through. These three scenarios can happen. How it will be gonna take in the consideration that I will be showing you in the practical. But these are the three I will say scenarios that happen for the SSL profiles. Any doubt to anyone?
Not yet.
Okay.
So in SSL offloading, the encryption will happen between client to F5, right?
Client to F5.
And SSL bridging, it is client to F5 and F5 to
F5 again encrypted.
Yeah,
And
F5 decrypt, and then we will encrypt to the server,
will
right?
encrypt. Right.
And SSL pass through, it will be end to end. There will be no role of F5, right?
Right.
Okay.
So F5 will not do any kind of encryption or decryption.
So in this case, a server will do the encryption or what? In SSL pass through.
Bridging and in SSL pass through. Server is doing the decryption as well.
Okay. Yeah, got it.
Same in the SSL bridging also, server is gonna do that.
So all certificate and key will be on server, right? In this case.
Both. On
Okay.
On F5 and on server.
Okay. Yep.
Now let me tell you one more thing. You asked a very good question. Let us say in this topology, you joined another company. Okay. In that company, the scenario is client going to internet to the INET router. INET router to maybe IPs. Maybe then riverbed device. Maybe then some kind of firewall, that is follow. Then it is reaching to the F4 and then going to the server. Now you tell me, if I need to do, let us say this server, application, whatever I am hosting on this server, cert is about to expire. Cert is expired. Now let me tell you, you need to involve this team. You need to involve this team. You need to involve this team, and along with that yourself and on the server side. Are you getting what I mean to say? All of these identities are full proxy.
So you mean we need to install the certificate on all these devices, right?
Yes.
Perfect. Yep.
Getting this point?
Yeah, it's clear.
Yeah.
No, I didn't get you, because if server certificate expires, why do we need to install in the other device?
So just focus on this word. Everything is full proxy.
Is full proxy work on end-to-end device.
So full proxy means that is the end point. And that is the reason that certificate should be there. Otherwise, how these devices will be able to decrypt it and able to scan the traffic. They cannot. Is it clear, Ines?
Yeah, I mean, it's clear. Is there any
Let me, okay,
production scenario you can tell? Because
this is a production scenario only, but let me just show you over here. If you see here, why we required SSL on F5 in the second number case, you tell me why it should
yeah,
be on F5.
okay, F5 so that the request coming from the client, it can do the encryption.
It can do the decryption, but why? Because server also need to have the certificate. Here, server should have certificate. F5 will also have the certificate.
Yeah, because F5 is intercepting and doing, intercepting and checking the traffic.
Very good. Now you own self give me the answer. Now you think what IPS is doing? Intercepting and scanning. So certificate should be there.
Okay.
What Riverbed is doing? Caching. If it cannot intercept, how it will be able to do that? Palo Alto, scanning again, securing your traffic. If it cannot intercept, how it can, check? Getting my point?
Okay, got it.
So that is the reason the certificate should be there. Any doubt to anybody?
Clear.
Next question. Client is coming through the internet, or maybe let me just remove the internet. That is already all of you are very mature, you are aware of it. I am saying there is a device. Then there is F5. And this is foolproof. Any device. And there is a server. Now, I am putting a certificate over here. I am putting a certificate over here. But this side, I am putting a public certificate. Here I am putting the private. Here I am putting the private. Now, let me tell you first the difference between the public certificate and the private certificate. Public certificate means that it is sent by some of the non-root C certificate authority. So in your browser, like if you just see that, okay, it is signed by the DigiCert, let us say DigiCert. Okay. So if it is signed by DigiCert, your browser is aware about it. But in your own enterprise, let us say if you have your own portal, like if you are working in any company, ABC company has their own portal for the timesheet, for the maybe a lot of other things, right? So that portal need to be get opened where? Inside into the organization. Let us say only accessible inside into the organization. Why this ABC company should purchase it from the public CA, okay, or the root CA? Why it should purchase from there? Why not to create their own certificate and just post it? Are you getting my point? So in that case, that certificate would be the private cert. Private certificate that is not generated by a non root CA, but that's all right. We can accept that. So let me tell you, whatever the first full proxy, that should be having the correct certificate. Rest of them, if you are putting the public, even that is fine. Even if you are putting the private, even that is fine. Is this part clear, guys? Are you getting my point?
Yes, Radhe, one
Yeah,
thing.
yeah, please continue. I'll ask.
Yeah, one thing. This devices, you mean the external facing device, which is like a proxy, need to be a public certificate.
That's true. That's true.
Am I right?
Yes, yes, you are.
Okay, got it. Thank you.
Yeah, my question is, okay, this device full proxy already decrypted. So after that, is it sending a decrypted plain text traffic or how?
Encryption only.
Okay, but those encrypted traffic will be with public key only, right? Then they should have a public certificate, right?
Don't worry, I will be gonna talk about the certificate handshake. Okay, sorry, TLS
Uh,
handshake,
one question
and
here.
you will understand more.
One question, Radhe.
Mhm.
When client is sending the traffic to device which is full proxy, it will. I'm talking about SSL offloading. So it will encrypt. Then the full proxy device will decrypt the traffic. Then again
And
it will.
end to end, it would be plain traffic in that case.
Okay. So after the full proxy to F5, it will be encrypted or
No, no,
plain
it will
traffic.
be plain. It will be plain.
Okay.
But what you can do is, like, if you have that kind of thing, that okay, it should be, or you can have this like from here to here encrypted, from here to here decrypted.
Mm-hmm.
You can do like that as well.
Okay.
So in that
Okay.
case, you don't require certificate on server, only on that.
Okay. Oh,
Now,
that is why it is client SSL certificate and server SSL certificate, right?
yes,
Okay.
that we will be gonna talk about.
Now I understood. Yeah.
Understood? Great. Okay, Younes, for you, please wait for some time. Okay, I will be gonna explain. Maybe let me see if I have that. Give me a minute. Okay, let me check. Maybe let me talk about that first. Okay, guys, please go to the blog.netminion. Okay, and from there you can go to this particular blog to watch out if you want to see about the TLS and SSL and so maybe let me go. You can read about these terms. So this is also again important. If you just see the line by line, that what is digital certificate? It is nothing, but it is a proof kind of certificate or digitally signed certificate. It is that okay, this particular website is having proper authorized thing from this particular root C, that kind of thing. And when a certificate is given, a public key is also generated, and there is a private key also. Probably let me talk about the private key and public key first before going through this document, so that you have more sense. Now I will be gonna show you also in the practical format, but in your FI also, it can be done through anything, through your Windows machine, CMD, through Linux server, through anything. Okay. But I will be going to talk with respect to the F5 only because that is the GUI part and the good part. In the F5, when you will go to the certificates, there is an option to generate the certificate. Okay. To generate the certificate, there is something you need to fill named as CSR, certificate signing request, if I'm not wrong. Okay. So what does CSR means? CSR is a bit like your Google form, where you need to tell that, okay, what is the subject name? Like my subject name is netminion.net. I will just say that, okay, my certificate name is netminion.net. Okay, who is the owner? Okay, which country? Like lot of options are there. Valid till how much? 3 years, 2 years, 1 year, bit like that. Okay. One name which is locally significant on the F5 box only. After this CSR, once you generate this CSR, you will have CSR plus a private key will get generated. Private key will get generated. Now, let me tell you one thing very important. You remember I talked about this topology that everybody should be having the same certificate. Everybody should be having the same private key as well. Okay. And who will send the private key? It is FI team if they are creating the CSR. It is PKI team if they are creating the CSR. Means it depends upon organization to organization. Who is generating that? If server team is doing, server team need to send it. Okay, that way. So a CSR plus private key, both will get generated. This private key is very important component. Do not share it with anybody. Okay, until unless it is a legitimate candidate and wanted to have it. Okay, need not to send it to anybody. This CSR is something like we are sending a form. This form need to be sent to the certificate authority. It depends, like your company using what kind of certificate authority. Like I gave you some name, DigiCert, OSPO, lot of CAs are there. Okay, so that CA will generate a certificate, and a public key will also get created. That is inside into this certificate only. This certificate and public key, maybe I will say that this certificate you need to import on your device. Import to your device. Okay. Any questions for this process?
So this certificate and public key needs to be, import on the devices, right?
See, public key is including into the certificate only, because that is a public.
Mm-hmm.
So we need to just import the cert. I will say the cert.
Mm-hmm. Okay.
Anybody else has any question? No? Okay. If no, now just let me remind you, this guy does not have the private key. Just for the sake of simplicity, I am just treating FI in between, none of the other devices. This private key is where? On the FI. And let us say this is SSL offloading. It is sending the plain traffic. It is the encrypted traffic. So SSL handshake will be gonna done between these two devices. How it happens? Very first, although I have created a document for you guys. You can please go through it, but let me maybe explain. Let it be like it. Let me explain over here on the whiteboard. So what happened is, very first time when this client opens a website, let us say abc.com, it will open a website, initiate a connection, and this connection would be your SSL connection. Please be mindful, SSL is no longer into the use. When I'm saying SSL, please treat it as TLS 1.3 only. But for the sake of just communicating, I would be gonna talk about SSL. So it will be sending the SSL request, like HTTPS request, probably I will say HTTPS to the F5. Why to the F5? Because it will go where? On the virtual server, and virtual server is where? On the F5. Once this request is there, server, or in our case the F5, will send the cert plus public. So second thing is, it will be gonna respond with the certificate and the public key. Now, client will just check with its root CA that abc.com is presenting me such and such cert and the public key. Is it okay? It is a yes, it is. Getting my point? So once it is getting authorized, client will ensure that this is a legitimate stuff, like the cert which is presented to me is the legitimate. Post that, whatever the strongest, I will say ciphers.
Cybersuits.
Okay, ciphers or cipher suites. Also, some people used to speak. That is also a correct pronunciation.
Okay.
And cipher suits also, both. Okay, if someone is speaking cipher suite, that is even correct. So they will just talk with each of them on the strongest cipher suits, whatever the strongest they can support, both of them. And there would be a mathematical calculation, I would say, that will get calculated. So that mathematical calculation will create some kind of a key over here and over here. Please do not get confused it with the private key or the public key. Those keys are in use to drive this key, probably let us say as a session key. Okay, so this is not the private or public key, but these keys are getting generated with the both of them. Now, whenever some data is coming, this data will be get encrypted with this particular key. The same derivation will be happen over here. It will be gonna decrypt this. Now try to understand.
And this is the key which we call session ID, right?
No, that is separate.
No? Okay.
But
Okay.
you can relate to that also session.
Okay.
ID.
Okay.
Okay. But okay, now what happens is this thing is named as asymmetric. Asymmetric, I will say the communication. And when the same key get derived, it is known as symmetric. Are you getting this point? Now let me go back to that particular slide. Oh, sorry, the blog. And now you read about this blog. Just go through it. Okay, I will be gonna through it, and you will be able to understand more about the facts how SSL happens. So HTTP means what? The plain thing, end-to-end plain. HTTPS means end-to-end. There is some kind of encryption. One thing. Eunice, are you getting this point?
Yes, I got it.
Okay. So what is digital certificate? Again, you can go through it. SSL, as I told you, it is a predecessor of TLS. Okay. Now it's not in the use. So people are moving to the 1.3. Okay. It is depreciated. Then if we talk about TLS, TLS is used for encrypting the data. All of the browsers use it. Okay, version 1.2, version 1.3, both of them are in the support. So if there is no encryption, but obvious the things can be done, these kind of things can be done in between. But if you are using SSL offloading, the SSL thing, it cannot be done. How TLS work? TLS is using two kind of thing. One is asymmetric cryptography. The term is okay. Asymmetric, as I told you, if you just relate to this is asymmetric. Right? What happens in asymmetric? In asymmetric, you have different keys. As I told you, using the public key and using the private key. This is private key. Using the public key and using the private key. First, the stuff would be happens. Then same keys will get derived, and post that there would be a symmetric thing, not the asymmetric. But this diagram is just showing you that there are two different keys. Okay. And to do the encryption and decryption, probably you can go through it. Cipher suits are there, and yes, more value if you are using it will be more secure. But let me tell you, such kind of computation requires a lot of resources. So you should be aware what kind of keys, what kind of cipher suits you wanted to look for. Symmetric, what? Symmetric means one key. Same key at the client side, same key at the server side. Okay. SSL handshake. So earlier there would be asymmetric thing, and then symmetric thing will happen. Both of them happen, and these are the 7 points what I was discussing. Okay, so these 7 points you can go through it. So these 7 points are very important. How the session get initiated through the asymmetric cryptography, and later on it will be get converted to the symmetric. Same thing shown into this diagram also, like client is sending the hello, cipher suits, TLS version, everything it is sending. And when server is checking this, it is talking about that, okay, this is my certificate and the public key and blah, blah, blah. Certificate get verified. If certificate is getting verified, session key is generated using the public key. Then it is checking that, okay, this is the certificate that is coming to me, and it will also generate the session key using the private key. Now master key is established at both of sides. Please do remember, they are not sending the private key to each other. No, these computations or these calculations are happening their own side, but calculation formulas are as such that both of the side the key will be get derived same. Okay, these are mathematical formulas again. Once this part is done, same key will be get generated over here, same key will decrypt over here. So this is the encryption done by the symmetric thing, and there is the decryption done by the same symmetric keys. Please ask any question. These are very important things. People used to get confused into this a lot. Okay. If you have any questions, speak up.
Yeah, my question is 4th and 6th, the session key generation with public key, session key generation with private key.
Okay. So as I told you, there are some kind of formula. Okay. So that formula will get applied over here. That formula includes the public key. Here, that formula will require the private key. By using these keys, some values will get derived. Bit like say, let's x equal to y. And in the last, we used to provide x equal to y. Remember? Same kind of thing is happening over here. We are taking a couple of the values, random values. We are taking a couple of the random values over here. But in the last, x would be equal to y.
Okay. Got it. So client, they require those public key for those generation for this session key, right?
So both of the sides, the session key will get generated. Okay, because client does not have the clarity on the private. Client does not have the private key at all. Who has? Server has, or in our case, FI has. So that is how this communication will get. Any doubt?
Can you go on the picture which you have created?
On the whiteboard, you mean?
Yeah, whiteboard.
This
So
one?
let's say the client is opening abc.com, okay, and when it will open, it will send the TLS and TLS information and cipher details to F5, and at the same time on the web server, let's say this the client is sent.
Web server is not into the picture yet.
Ultimately, abc.com.
It is F5. It is F5.
No, I mean, let's say abc.com ultimately is hosted on web server, right?
Let me tell you, the same communication will happen from F5 to the web server.
No, my question is, let's say they are using TLS 1.3 and my server is on TLS 1.2. Will it work?
It will.
Okay.
Because you just think logically that from client to the F5, the communication is ending over here. It is F5 who is generating the communication again. This is first, this is second. Here can be different ciphers.
Mhm.
Here can be different ciphers.
Okay. And we need to set up the configuration in the same way on F5, right?
Any other questions?
So if we need to change the TLS, so can we change on F5, let's say 1.2 to
I will show
1.3?
you. Yes, that part I will show you in the
Okay.
practical.
Okay. Give me one more set.
Sure. Take your time. Take it.
And regarding ciphers, so do we decide, mention or decide somewhere which ciphers would it will use, or it match automatically with each other?
See, we can decide also that okay, such and such suits is the minimum criteria that the client should come with if client is supporting. But otherwise, they mutually decide among themselves that okay, we will be gonna talk on this. As you know, Sachin was asking that either can we disable something or not. So we can disable also. Like we don't want SSL. Let us say one client is very old and it wanted to negotiate on the SSL. So we can just kick that out. We can just make the settings that no more SSL, no more probability as 1.1. So bit like that we can do it.
Okay. Yep.
Sure. No other doubt?
No, as of now. Yep. But tomorrow I think we will have.
Yeah, sure. But yeah, go through it. Go through it. You can even download in the form of PDF. Just click over here and you will.
Yeah, it is a good document here.
Please go through. Yeah. Now we were talking about the SSL termination advantage. This was our slide, right? And we just went into those documents and everything. So what are the advantages? Probably now you can able to understand. BigIP will perform all of the SSL key exchange and bulk encryption. See, I was talking about only one application. There would be hundreds of applications that is getting onboarded on that side. All of those things will be gonna done by whom? The encryption decryption by the BigIP. If you are using SSL offloading, which is the case of 90% of the application. 90% of the application will use SSL offloading only. Okay. So centralized management is there, and you can offload the SSL traffic from the web server. Let's talk about something, the profile dependency. So OSI model, everybody is aware, the 7 layers model, right?
Yeah.
So in 7-layer model, we have different traffic. Similarly here, if you see, it is talking about the same. It is saying, if you need to apply the cookie persistence, let us say, cookie is the profile, right? And if you need to apply the cookie profile, we already talked about it. You should be what? You should be have the HTTP profile. And for HTTP profile, what you should have? You should have TCP profile. So these profiles are known as dependent on each other. Dependent on each other.
Okay. Which means whenever we are configuring, we should ensure that when we configure cookie persistent, HTTP and TCP profile also should be enabled.
HTTP and TCP must be there, otherwise it will throw the error.
Okay.
I have shown you even in the lab. Okay. When we
Yeah,
were trying to put the cookie profile, it was throwing the error that no HTTP profile is there. Okay. Similarly, some profile cannot coexist. Like if you are using HTTP, you cannot put the FTP, either HTTP or FTP. If you are using TCP, you cannot put the UDP, right? Because both of the workings are separate, right? So this is known as your profile dependency. So probably you can just think about your OSI model, like application layer is depending upon the presentation, then on maybe session, then maybe network, then maybe with like your data link or the physical. Similarly, the profile dependency occurs in case of F5.